Thank you so much for stopping by. I am pleased to introduce Dan Mckean and George Hantzaras, respectively, on product and engineering for the next talk. So please put your hands together and welcome Dan and George.
Thank you very much. Hi, welcome to our presentation and demo about building a self-service database as a service for your internal developer platform. My name's Dan Mckean. I'm a product manager at MongoDB. I'm joined by George Hantzaras, who's an engineering director also at MongoDB. Together, we're responsible for enabling our customers to use MongoDB in two ways. Self-hosting in Kubernetes using our enterprise or community Kubernetes operators, or using our Atlas Kubernetes Operator, which is designed to manage and configure our Atlas developer data platform via Kubernetes. We're going to start with a story to set the scene. A small team of developers was working hard to hit their deadlines. As usual for them, they were managing their infrastructure using manual processes, including configuring their MongoDB community database. This had worked well for a while, but as the team grew, they had more services to manage while onboarding more people to the team. One day, two developers, Jack and Jill, were working on different projects, but they were using the same development database. Jack made a change to the authentication mechanism used for users, and Jill made a change to enable TLS. They both lost access. Fortunately, the database wasn't customer-facing, and they were able to fix the problem, but it did take them a while. Hands up if anyone here has tripped over somebody else's changes in the course of their work. Quite a few of you. Not an unusual problem. They needed to find a better way to manage their configuration.
So in this talk, we're going to build upon the story. We're going to talk about the evolution of the team's tooling and processes. We're going to talk about how the team changed their approach to managing changes and addressing their immediate needs to solve this problem. And then we're going to talk about how they began to improve their tooling and processes across their own services and systems, delivering a better developer experience for themselves, improving security and automating some of those processes. Then we're going to talk about how the whole company took a step standardizing across the board, delivering a huge array of benefits that would be critical to help the company scale and succeed. Finally, we're going to show you how you can achieve the same benefits.
So, back to the story. Following the incident, as you would expect, they had a retro, and they realized they obviously needed to do two things. Identify the problems in their current approach, and identify some solutions that would prevent this happening again. And they quickly realized that it all came down to managing how they made their changes. They tripped up on a few overlapping problems. Team visibility and awareness of changes. Neither of them had made an unreasonable change, but because they weren't aware of each other's changes, they tripped up on each other's changes and it caused a problem. Peer reviews. Better than relying on human communication, they could have done peer reviews like they already did for code changes, but they didn't do them for infrastructure changes. And they had no easy way to revert their changes. Perhaps you've guessed the solution they landed on.
It was infrastructure as code. They needed to store their infrastructure configuration in their existing code management systems. Since they were already using GitHub for their project using the database, it seems like an excellent place to store their configuration files. This had a number of benefits. First off, pull requests that each other could see, peer reviews from other team members, and if they still managed to make conflicting changes, they had an audit log where they could easily revert them.
Once implemented, this all worked great, but there was a catch. They'd implemented this for the system that they tripped up on, but they hadn't gotten around to doing it for the others they owned. As a result, each of their services were managed differently, using different tooling and different processes, and even different types of infrastructure. And this was costing them. They had too many tools and processes. It was hard for existing team members and even harder for new starters, and hiring people with the right kind of experience was tough. In the systems where they'd not yet adopted infrastructure as code, over time they were also seeing the configuration drift as people made small changes that made anyone knowing where the system was at tough and made troubleshooting really hard. They were experiencing infrastructure drift. And lastly, the security team was struggling. Too many people had too many rights on too many systems for them to keep track of, and it didn't adhere to the policy of keeping permissions to the minimum possible.
They needed to standardize their team's tools and processes. So this time there were several changes they discovered that they needed to make. And while none of them came for free, they already had some success stories in their existing systems. First off, a standard platform was the first solution, and Kubernetes was their choice for a few reasons. Kubernetes offered self-healing, declarative configuration, an active ecosystem of complementary tools, extensive global scaling, and a high level of customization and extensibility. One of the systems was already running on Kubernetes, so they had already started building the knowledge necessary to migrate. They also settled on the standard way to manage their infrastructure and application. Namely, they were using infrastructure as code. As we heard, solving their initial issues, they had early success with that. And this time they took it a step further. They decided to use a GitOps approach, and they selected ArgoCD for continuous deployment since it worked so well, it integrated so well with Kubernetes. This gave them a consistent and reliable method to automate applying their infrastructure configuration files from their repositories into Kubernetes. Finally, this helped them have fewer tools and processes to worry about, so they had more time to work on their application. As a result, this increased their velocity, and not to mention their happiness. It also limited the rights and permissions they needed, making the security team more happy as well. And it also simplified the job descriptions for any new hires onboarding in the team.
So at this point, our team was running like a well-oiled machine. But as they'd been making this journey within their own team, problems began to surface across other teams. Alignment across the teams was becoming an increasingly hot, sometimes heated, topic of conversation. No two teams worked in the same way. Engineers moving between teams had to re-onboard due to different processes and tooling. Any new team had to decide and implement their own method of managing their systems. And this meant reinventing the wheel each time. Governance and policy enforcement were hard. It was hard to create a policy that could apply to all teams, given that they used different systems. And making sure that they adhered to the policy was even harder. Finance weren't happy either. It was hard to attribute costs to teams or projects. And finally, self-service on what little shared infrastructure existed was tough, given that it had to be integrated into the team's Snowflake systems.
So all of these problems created, again, a lot of discussions. Eventually, the leadership decided that they needed to make an extra investment to standardize across different teams. First off, they decided they needed an internal developer platform, an IDP. It needed to be centrally owned, centrally managed, and highly self-service. A critical part of their IDP was a database as a service, or a DBaaS. Every team needed to store their application data somewhere. So they started the discussion to try to identify the main components of their IDP. And after speaking with individual teams, locating successes that different teams had with existing services, they started making some choices. First off, Kubernetes was an easy winner for the underlying platform infrastructure. The Cloud Native Computing Foundation estimates that 70% of IDPs are built on top of Kubernetes. So they started thinking that there's a lot of knowledge out there that they could take advantage of. They also felt safe because of the lack of vendor lock-in. Most of the major cloud providers offer managed Kubernetes services, and this would also help them cut down the cost and time to market for their new platform. For their DBaaS, MongoDB Atlas was the top choice. Since Atlas is already an as-a-service offering, many teams already using it could see great cost benefits and even bigger time savings. They also wanted to experiment and saw massive benefits from the developer data platform tools that Atlas offers, like Atlas Search Analytics, support for mobile apps, as well as serverless, time series data, geospatial data, and multi-cloud global distribution and resilience. This made it an obvious choice to plug in with their existing IDP. For code management, they decided to stay with GitHub. That was used by most of the teams. So the only thing they had to do was to manage their infrastructure as code files in the same way they manage their code in the existing repositories. ArgoCD was the grid mechanism to bridge the gap between the infrastructure as code files in the repositories and Kubernetes. This gave them a highly automated and standardized GitOps workflow. And in doing so, they cut down the expertise and, most importantly, the permission that individual teams and engineers needed. Finally, they chose to use the MongoDB Atlas Kubernetes Operator. It's built to support infrastructure as code and the GitOps approach through Kubernetes, so it made the developer workflow much easier. So the Kubernetes Operator is a service that is designed to extend the default control plane functionality of Kubernetes in order to support custom logic for specific application, in our case, for Atlas. So the Atlas Operator enables you to use the same tooling and processes to manage Atlas that you are using to manage your other Kubernetes deployments. So although Atlas doesn't run in the Kubernetes cluster, the Atlas Operator allows you to use declarative configuration that can be applied into Kubernetes. And then through the Atlas Operator, those are applied via the Atlas Admin API in Atlas. So the configuration files, the infrastructure as code files can be stored alongside the rest of the configuration of your application and applied into Kubernetes using tools like ArgoCD. Better yet, a central team responsible for Atlas, in our case, our central platform team, is responsible for Atlas usage and can produce templates. They then simply, in order to create a new database, it's as easy as copying a template in the repo, customizing it, and then just pushing it in the repo and watching a pipeline of ArgoCD and the Atlas Operator create the new database in a matter of minutes. Suddenly, databases were a lot easier to create and manage, and better yet, it was super self-service. There was no need for DIY creation or asking a central team for help. The operator also helps prevent configuration drift. When the source of truth is a repository, it's not great to have changes applied directly into the infrastructure. The operator does periodic reconciliation to ensure that the Atlas resources stay aligned with the configuration files stored in the repository and applied into Kubernetes. So any ad hoc changes made through other configuration interfaces like the UI are going to be overwritten according to the config files via the operator. So this helped the company ensure that any changes were made through a standardized way. The Atlas Operator has been in development for a bit over 2 years. It's been in use by customers for most of this time, and it's been in general availability for over a year now. It has a dedicated team of 5 working on it, so Jack and Jill's team started to understand that they could trust it. Finally, it has great support and an ever-growing coverage of Atlas's many features.
Jack and Jill's team and company finally landed on building this IDP and DBaaS with a GitOps workflow to enable self-service. But Jack and Jill made their journey over time and over a few iterations and some hard-learned lessons. Had they known where they'd end up, they'd have likely taken a much more direct route to the end solution of the IDP and DBaaS. So that's what we're going to show you. Our shortened journey is split into 3 parts. Deploying and managing Atlas resources through the Atlas Kubernetes Operator, ensuring that developers can manage the Atlas configuration in the same way that they manage their configuration of their stack actually running in Kubernetes. Secondly, automating the process through a GitOps approach through GitHub and ArgoCD, making it self-service, scalable, and adhering to IAC principles. And lastly, we're going to show you just how easy it is to connect an application to your Atlas database when you're using the Atlas operator, because it creates a secret automatically that you can use to connect to the database. All of this will show you just how easy it is to get up and running using MongoDB Atlas as your database as a service in a Kubernetes-based internal developer platform.
So when Jack and Jill's company decided to use Atlas to integrate a DBaaS service into their IDP, the Atlas operator was the obvious choice. The operator can be installed in a few different ways, using kubectl, Helm charts, or starting with version 1.7, the Atlas CLI. So the CLI is what we're going to be using in the demo, as it makes it super easy to install the operator, and most Atlas customers already have it installed. So by running the Atlas Kubernetes Operator install command, we not only install the Kubernetes operator in our cluster, but all the necessary setup happens, such as creating new API keys for the operator to communicate with the Atlas admin API. We can see the operator pods running in our cluster now. And going into the Atlas UI, we can see the relevant API key has been created by the Atlas CLI. And we can also see that this API key is safely stored as a Kubernetes secret in order for the operator to use it. So now that the operator is installed, the next step is to set up the Atlas project. So we can see the Atlas project is simply defined as a YAML file. A simple kubectl apply, and we see that the custom resource has been created into our Kubernetes cluster. And now under the hood, the operator reads this custom resource and via the Atlas admin API creates the project in Atlas. So back to our editor, we can now deploy our first cluster. Again, in a simple YAML format, we define our Atlas deployment. And amongst other things, we can define the instance size, the cloud provider we want deployed, and the region we want the cluster to be deployed in. As before, after running the kubectl command, we can see that the Atlas deployment resource is running on our Kubernetes cluster, and the new cluster is being created in Atlas.
Using the operator enables you to manage Atlas in the same way you manage your stack running in Kubernetes. But it didn't solve all the problems that the team had in the story. Complexity at scale. In a company with many services and many engineers, you need tooling that scales and standardizes across teams. Rights and permissions. It's not a great idea to allow every developer to manage their production Kubernetes instances and deploy services directly into it. And without self-service and automation, there's a lot of work done manually, and every new engineer has to learn how to do it.
Well, engineers don't really need and they don't want to manage Kubernetes clusters. They want to focus on writing their application code. So infrastructure as code stored alongside their application code in the repositories is part of the solution. But Jack and Jill realized early on that they should take it a step further. So Kubernetes clusters centrally managed with ArgoCD installed provides a level of automation that saves engineers from managing their services directly in Kubernetes. So installing ArgoCD is a pretty simple process for our platform team. So first of all, we need to create a new namespace for Argo components to run in. Installing the ArgoCD operator is automated by an install script, and it only takes a single command and a few seconds. A few less seconds, this is the video loading. Okay. Perfect. So we can now see that all the Argo pods are running in the ArgoCD namespace. So we're good to go. So first we need to create our DBaaS application in Argo. So all we have to define is the repository that we're gonna put our IAC files, as well as the destination cluster that we're gonna be deploying our services. Now and we just apply this. Now going into the Argo UI, we can see our DBaaS application has been created, and we can monitor the sync status with our repository. So from this point, we don't need any Kubernetes access. Deploying our new project, similar configuration file as before. The only difference is instead of kubectl apply, we're gonna do a git push into our infrastructure as code repository. ArgoCD now picks up the changes in our repository and deploys the custom resource in Kubernetes. And we can see that the Atlas project custom resource has been deployed in our cluster, and the operator has picked that up and is now running in Atlas. So in order to create a cluster, again, we use the same YAML file as before. Same parameters, we just change the cluster and project name, and through a simple git push, all the magic happens under the hood. ArgoCD picks up the changes in our repository, deploys the new custom resource, and the operator in turn deploys our cluster in Atlas. Now that our team started deploying their databases through a GitOps approach using infrastructure as code, let's see how easy it was to connect all of their applications to their databases in a Kubernetes native way. For this part, we'll be using the Atlas database user resource. Since each of these Atlas database users is just another file in the repository, just another YAML file, the operator, and Argo makes managing and deploying them super easy. So we've already created a Kubernetes secret which contains the user password. And we define the Atlas database user custom resource, which refers to this secret as the user password. As before, we utilize Git and our GitOps approach in order to deploy. ArgoCD picks up the change and deploys our database users. Now, additionally to creating the user, the operator creates a Kubernetes secret named after our project, cluster, and username combination. So this secret contains all the connection information that our deployments will need in order to contain to the database. And further exploring the secret, we can see the connection string that we need to refer to when we're deploying in Kubernetes. So as an example application, we're going to create a Kubernetes deployment. We'll use the official Mongo image in order to deploy a Mongo shell. And we'll use the connection string, we'll use the secret as an environment variable. We deploy our Mongo shell in the Kubernetes cluster. And we can see now that the pod is running in our cluster. Now, to verify that it has connected in our database, all we have to do is read the logs of the Mongo shell pod, and we can see at the bottom that it has connected in our Atlas database. So this was the end of the demo, and I'm pretty sure you were expecting something spectacular and fireworks towards the end. But we have the philosophy that when it comes to managing critical infrastructure in production environments, not having fireworks is a good thing. So with all these done, we've reached the point where Jack and Jill's company did, with an awesome database as a service on top of our internal developer platform. So if you also want to kind of experience what Jack and Jill's team did, and you want to go through this DBaaS journey, this is a good time to take out your phone, get ready. In about 2 slides time, you'll see a QR code in the screen which can help you throughout this journey with code examples and a very simple step-by-step process.
As with many things, the value of the whole is greater than the sum of the parts that we just showed you. Each of the components, from Kubernetes to ArgoCD to Atlas itself and the Atlas Kubernetes Operator, each provides value in isolation, but it's in the overall IDP and DBaaS that they all really shine together. Self-service empowers users and is almost always faster than having to ask someone else to do something for you. Central teams can focus and support of the other teams and improvements to the central system that all those teams benefit from. Developers are free to focus on value-add work, often leading to increased innovation, shorter time to market, and greater productivity. More rapid onboarding and internal movement between teams is suddenly possible because you have a consistent approach across teams. And for the same reason, cross-team collaboration is also possible now. You also get massive cost savings. You're using fewer tools and you get a better ROI for the effort spent to maintain and develop the systems you're using. And the developers are hopefully happier and more engaged, and everybody loves a happy developer. Overall, a well-implemented IDP and DBaaS can contribute massively to the success of a business, from reducing costs to improving innovation to shortening the time to market. All of these things help a modern business succeed, where a great idea alone may not be enough.
So if all of those problems that you heard sound a bit familiar, or if you just want to experiment with a DBaaS in your development lifecycle, you can just go ahead, follow the link in this QR code, and you'll be able to see the code that we showed in the demo today, as well as a step-by-step guide how to follow this. In the repository, you'll find the code example for how you can use the Atlas operator to manage Atlas resources, a GitOps approach in order to make that self-service and scalable with ArgoCD, and an example of how you can connect your applications to your Atlas resources through Kubernetes primitives.
And lastly, we'd love if you could leave us some feedback and let us know if this was a helpful session or if there's anything extra you'd like to know next time. Thank you very much.